Hi everybody, and so we're going to go into continue talking about how to graph certain trigonometric functions, and we're going to talk about the phase shift, which is just a fancy way of talking about the horizontal shift of sine and cosine curves. We're just going to be focusing on those in this section. Now, a lot of the actual principle here you've probably seen already before, because if you remember how we shift a graph to the right or to the left, we just replace x with x plus a number or x minus a number, right? So, and it's just, the thing is, the shift is actually counterintuitive with what you think. When you replace x with x plus k, you're actually shifting it to the left. And when you replace x with x minus k, you're shifting it to the right k units. Okay, so that's why if we take sine x and replace sine x with sine x plus k, we're shifting it to the left k units. All right, so we have this cycle that now begins at minus k. And this kind of makes sense, because if you were at this point, if you plug x equals minus k in here, you get this. This is 0, and sine of 0 is 0. So that kind of makes sense. Same thing over here. If you replace x with k, you get sine of 0. That's 0. So you get this shift. Okay. So this is something we already knew before from other classes. Now let's say so. Now if we take the sine of bx and we want to make a shift of that. Well, first of all, let's remind you that this b here determines the period. So the period of this one is going to be 2 pi divided by b. And then now if we want to shift it now, let's say we want to write sine of bx plus, replace bx with bx plus c. Well, we're not really shifting it c units, because we're not replacing x with x plus c or x minus c. We're actually replacing, in this case, because we can factor out a b here, and this is b times the quantity x plus c over b. So we're actually replacing x with x plus c over b, which means this is a shift to the left, c over b units. So we say the phase shift in this case would be minus c over b, and that's the phase shift. And so that's how we get this graph right here. Okay, I should say that of course b and c could be positive or negative, but the phase shift is always going to be minus c over b. So sometimes the phase shift will be negative, sometimes it will be positive. A negative phase shift means we're shifting to the left. Positive means we're shifting to the right. And notice that if we're shifting this, whenever we shift this point, we also have to shift this point and all the points on the graph. So that's why we have the period is still going to be the same. So we have this distance from here to here is still going to be in this case 2 pi over b, which is the period. The same thing exactly happens with cosine graphs, right? If we have the cosine of bx, looks like this, and then if we replace bx with bx plus c, that has the effect of replacing x with x plus c over b. Once again, we're shifting it. The phase shift is going to be minus c over b. Okay, again, we're not always shifting it to the left. Okay, if minus c over b happens to be a positive number, then we'd be shifting it to the right. Now, if we put everything together with other stuff we've learned, we are now in a position where we can graph functions whose equation is in the form a times the sine of bx plus c plus d. Because the a, just remember, it determines the amplitude, and the d is just going to be the vertical shift. Now, how we shift this, right? So in all of these, there was no d over here, right? The d we had a plus 0 here, so that's why this graph was centered on the x-axis. But if you put a plus d here, then you're either going to be shifting it up or down. Okay. So the absolute value of a is the amplitude. 2 pi over the absolute value of b is always the period. Minus c over b is the phase shift, and d is the vertical shift. And in this case, it's always good to know what's the largest value of y can be and what's the smallest it can be. Well, it's all about what's the largest the sign of anything can be. The sign of anything, the biggest that this thing can be is 1, right? So this would be, in that case, y would be equal to a times 1 plus d, or just a plus d. And the smallest this would be a times negative 1 plus d, or that's the same thing as minus a plus d. So you can see that the y values range from a plus d to a minus d. All right, where it's centered at on the horizontal line at d. Okay. So, and I didn't draw this, but of course you can see the same thing happens with cosine. Okay, the cosine is just this curve will look like a cosine curve instead of a sine curve. Okay, so let's look at some examples how we can do these. Again, without a calculator. So we look at first sine of 2x plus 1. Let's first find out a. There's a 1 in front of okay, the a is 1. The 1 is kind of implied here. B is 2. C is 1. And D is 0, because there's no constant out here. So we can right away we can see the amplitude is 1. The period is 2 pi divided by 2, which is just pi. And the phase shift is minus c over d, so that will be minus 1/2. Okay. And of course the vertical shift is going to be 0, which we don't have to make a note of that, right? So if we were to graph this, really you want to start by just trying to graph one cycle of the graph, okay? And you start with the phase shift, so that's going to be negative 1/2. Okay. And then then over here is the end of the cycle would be negative 1/2 plus pi. Okay, we're not going to worry about what this number is actually. Okay, well we now know that and then the sine is just going to go like this curve here. You might want to estimate there's a halfway between this point and this point will be in this point right here. That will be negative 1/2 plus pi over 2. If you want to, and the reason for that is because the distance from here to here is pi, so from here to here must be pi over 2. And then the graph looks like this. Okay, where the amplitude again is 1. There's no vertical shift, so it looks like that. All right, and then you can if you want you can graph some more. You can extend the graph like so, if you want. All right. Do another one. Cosine of 3x minus 2. Okay, in this case, a is 1 again. B is 3. C is negative 2. And D again is 0. Okay, so the amplitude is 1. The period is 2 pi over 3. The phase shift is 2/3, right? Because we change the sign of minus c is positive 2, so it's 2/3. And there's no vertical shift. So, okay, so now the phase shift, well, here's 2/3. And the way down here is 2/3 plus the period, 2 pi over 3. Okay, now, and again, you can plot this middle point if you want. This would be 2/3 plus half of 2 pi over 3 would be pi over 3. Okay. All right, and then the thing to remember is that this is a cosine function, so you want to stop at the top. And if we actually, if you just plug 2/3 in here, you can see this is just the cosine of 0, which is 1. So that will be up here. Okay. And you'll check that if you do this down here, you'll get cosine of pi that's -1. So here. So you get this cosine curve like that. And again, since the amplitude is 1 and there's no vertical shifts, y is just ranging from 1 to -1. Okay. Just focus on that. Okay. That's good. Okay. Well, example 3, and by the way, again, we could just continue this. By the way, I should say in this case, the y-intercept, if you try to do this, this will be the cosine of -2, and you don't really need to. In this case, I'm not going to be too concerned about the y-intercepts because a lot of the, you'll get something like the, a cosine of -2 or the sine of 5 or something like that, and we haven't memorized those. Okay, so we're not going to do that. You can use your calculator to, if you really want to see, you can use your calculator to see what the y-intercept is. Maybe a couple things is, though, that the x-intercepts, I should say something about the x-intercepts. The x-intercepts are going to be where, in this case, where the cosine is 0. Well, we can see that at this point, the x-intercept is going to be halfway from here to here. So that would be half of pi over 3 would be pi over 6. So this would be 2/3 plus pi over 6. That would be one of the intercepts. And then this would be, and then from here to here is 3 times this distance. So this would be 2/3 plus 3 pi over 6, or 2/3 plus pi over 2. But one thing you might want to do if you want to find the x-intercepts, you set cosine of 3x minus 2 equals 0, and the cosine of anything, if it's equal to 0, it's going to be like plus or minus pi over 2, plus or minus 3 pi over 2, and so on. So you would have to add 2 to all of these, and then divide by 3. Okay, so okay, so you can do that, but maybe I'll just do it this one time. So this would be plus. Okay, and then divide by 3, and that would be plus or minus pi over 6. Plus 2/3, plus or minus 3 pi over 6, plus 2/3, and so on. Okay, so not exactly nice numbers, but you can do that. We'll do more of these when we get into solving trigonometric equations. Okay, right now I just want to make sure you're able to graph one cycle of this. Okay. Let's look at example 3. Y equals 2 cosine of x minus 3 minus 4. In this case, A is 2, B is, this is 1x, so this is B is 1, C is -3, and D is -4. Okay. All right, so the amplitude is 2. The period is 2 pi, divided by 1 is just 2 pi, and the phase shift is 3 over 1, which is just 3. And the vertical shift we can see is -4. Okay, so when we graph, this, we're going to see most of the action. Actually, the entire graph is going to be below the x-axis. And here's 1, 2, 3, 4, -4. And the graph will be centered along this line here at -4. And you can see that the biggest this can be, when the cosine of x minus 3 is 1, you get 2 times 1 minus 4, that's -2. So that's up here. And when the cosine of x minus 3 is -1, you get -2 minus 4 is -6. Okay. So your y values are going to be between -2 and 6. Okay. And then, as I said, the period is at 3. Okay. And then one period ends later at 3 plus 2 pi. Okay. So now you can plug 3 in here and easily see that this is cosine of 0, that's 1, so 2 minus 4 is -2. So we're at this point. Because it's periodic, we have this point as well. And halfway in between here is 3 plus pi. If you plug in 3 plus pi in here, you get cosine of pi, so that'll be 2 times -1 minus 4, that'll be -6. Okay. And then you know this is a cosine function, so it will look like this. Okay. Okay, and then curves like that and repeats. Okay. Okay. Now I didn't draw this, but the amplitude is 2. It doesn't look very big, but the amplitude is supposed to be 2. Okay. So that's what this looks like. All right. Let's look at example 4. Where, in this case, we have the sign of negative sign of 4x minus 3 plus 2. So in this case, A is -1 now, B is 4, C is -3, and D is 2. So the amplitude is 1. The period is 2 pi over 4, which is pi over 2 after we simplify it. The phase shift is equal to 3 over 4, right? Negative C over B is positive 3 over 4. And then the vertical shift is 2. Okay. Okay, so now all right, so let's first, here's the vertical shift is 2, so we will have this vertical line at 2. And the phase shift is 3/4, we said. Okay, and here's 3/4 plus what the period is, pi over 2. Okay, so that's one cycle. And let's just see, let's plot some points at 3/4. If we plug 3/4 in here, we get the negative sign of 0, right? Because if we check that sign of 4 times 3/4 minus 3 plus 2, the 4's cancel. 3 minus 3 is 0, so this is just going to be minus 0 plus 2, which is 2. Right, so we're right here at this point. And you can see that that will be this point as well. Now the thing here is that you have to worry about this minus sign. So you'll see that there's going to be another point here, halfway in between here, and that will be right there. But because we have a negative sign here at this point, so let me just say that this is, so the graph is actually going to go down first, and then it's going to go up. Okay, so so here, by the way, here's 1, and here's 3. And we know that because the amplitude is just 1, so we're only just going to go up 1 or less. We can also see these are the largest and smallest that y can be. So it will be like this. Okay. And actually this is going to be 3/4 plus pi over 4. The valley right here is actually at 3/4. X would be 3/4 plus pi over 8. But if you multiply this by 4, if you take this number and plug it in here, this turns out to be the negative sign of pi over 2. And so this will be negative 1 plus 2, and that's 1. So it does work out. Okay. All right. And then, okay, I will let, I'm going to take a break here, and I'll finish this up in another video. We'll do the last 3 examples in the next video.